So what are exosomes for me? So exosomes, also called extracellular vesicles, are small membrane encapsulated bubbles that are released by all cells. They're really tiny, so one cell can release 1,000 of those over a short period of time, and they're really, really very small. And the interesting thing with these things is that they can send messages, advanced messages, from one cell to another. They contain a lot of different molecules that can change the phenotype, the response, or the function of a cell that takes them up. Do all types of exosomes or extracellular vesicles work the same way? And the answer to that question is very simple, it's no. So it depends very much on which cell produces this exosome. So a bacterium, for example, can release an exosome that is very inflammatory, makes you very sick. Whereas a mesenchymal stem cell exosome can be anti-inflammatory and even be used as therapeutics to treat inflammatory disease. How do you obtain pure exosomes or pure extracellular vesicles? And that's actually quite a tricky question. So if you isolate the vesicle from a cell culture medium, there are multiple techniques that are required, quite advanced techniques, to concentrate that cell culture supernatant, the conditioned medium that is full of exosomes, but not very highly concentrated exosomes. So you need to do concentration steps and purification steps that use tangential flow filtration and sometimes chromatography to make them pure. If you try blood, for example, it's almost impossible to isolate pure exosomes from the blood, because the blood is so full of contaminants that are very similar in size, for example, and density as the normal cell-derived exosomes. So the question is whether plant stem cell exosomes, the plant stem cell extracellular vesicles, and plant extra vesicles the same thing. And the answer to that is simple, it's not. So a plant stem cell can produce exosome-like particles, vesicles, that seem to have some of the similar properties as mesenchymal stem cells do. Now when you put a fruit or juice or a plant in a mixer and mix it very hard, you also get nanovesicles, but they're not naturally produced, and they're basically a fabricated type of vesicle. So the question is, how do you get the different vesicles from a plant extract or the stem cell? And when you culture this plant stem cells, for example a rose stem cell, you culture it in medium, and the vesicles are spontaneously released from the stem cells into the medium, and they're isolated from that medium with increasing concentration and purification. Now a nanovesicle that is produced by a mixer or by force is not naturally released. So the question is, how can you check whether different types of products, I presume in the cosmeceutical field, have real extracellular vesicles or exosomes in the actual product? And that's actually a not so easy question. So basically you can look for different components of the vesicles. For example, you can take electron microscopy pictures, you can look at RNA content, you can do types of proteomics analysis of those products to see whether there are components of vesicles in them. I don't think anybody has yet really done a full comparison of the different types of products for quality assurance purposes. So the question is whether you can produce exosomes or extracellular vesicles directly from blood from the same patient and give it back to the patient. The answer to that question is simple, and it's no. It's very, very hard to isolate extracellular vesicles from blood, and we should know that the blood exosomes are actually primarily from red blood cells. So that's the dominating vesicle in the blood, and it's also from platelets. So there are many other types of components and growth factors and cholesterol-containing lipoproteins in the isolate that you get from the blood. And the number of exosomes is exceedingly low in those isolates.